Okay, just in case you are not sure, you can confirm whether you're muted or not. If you need, you can make sure you're muted. Okay. Just confirming for the stream that the stream has started. Oh, my volume. Hmm. Hmm. Yeah, put the microphone up just a bit. Okay, you can confirm that you can now hear me loud and clear. Put my microphone closer to me. Awesome. Thanks so much for that. Happy to hear you guys are doing well. Let me just make sure that I'm having everything set here. That's on my second screen. And awesome. Okay. Yeah, now officially welcome you to the midpoint pulse check, for the 30-day Terraform challenge. Right now, I can tell you the LinkedIn algorithm is already thinking that the only thing Kevin loves is a 30-day Terraform challenge. Why? Because I keep on seeing your amazing posts right there on LinkedIn. As you keep on doing these, we're really, 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 really overwhelmed by the way you guys are showing up, staying consistent. And as usual, there have been casualties along the way. That is why everyone can now fit into the Zoom call compared to last time around when we couldn't have all of you on Zoom. Then we had to decide on just going on YouTube. But now we are back on Zoom for a more up close and personal interaction as we take stock on the 2 weeks so far as we get into the last 2 weeks. And before I usher in James and Nelson, I'd like to first of all shout out to each and everyone who has been building in public, putting out your articles, putting them on LinkedIn, putting them on X, wherever, and putting them also on the WhatsApp groups just to let us know that you have done the work. And also, more often than not, we've seen you put it also on our EveOps platform. You've done amazing job and continuing to not just do for yourself, but to also support others actually in the community. So yeah. So, and as always, before I get onto these, we have been seeing your work. We've been seeing the amazing things that each and every one of you have been doing. And we have some of the most outstanding talent, a community spotlight for three amazing individuals who have been participating in this 30-day Terraform challenge, and you'd like to give them a shout out, especially if they're here in this room. We'd also want to give them an opportunity to just say hi to us, tell us what they've been doing different so that others can get into that spotlight next time round. So let me get the flyer up. It's coming on my screen so that I can share that with you guys. And we can you, who can, really wish someone can gaze it out and see whether someone can be able to guess who these amazing individuals are. Okay. So let me share my screen. So we just to mention is these not just people on the leaderboard. It means that you're looking at people who have been doing an amazing job across the community, not just posting and getting the points. Yeah, so let's get on to these. Should be able to see this. Should be coming up. Kindly confirm to me once you're able to see this app itself. If not, please also let me know if it's still coming up. Awesome. I think I can see it's up. Yeah, so we would like to really put a shout out to it seems it was a battle of the Graces, right? So we're having Grace Zawadi, who is a full stack developer. We have Grace Kihonge, who is a cloud DevOps engineer, and Nemea Nzuzi, who is a cloud DevOps engineer. Let's give them a round of virtual applause. You can use the React icon on your Zoom just to appreciate these three amazing individuals who have been putting in the work currently in the community. I know there are many more, but these are some of the top and the most outstanding talents that we've seen participating in the community. So please let's give them a shout out. And if any of them is here, please like to please raise your hand. We'd like to give you a few seconds to just tell us how things have been for you. And yeah, so yes, Nzozi, please, by all means, the mic, you can please also, if you can turn on your video. We'd like to see you. Let me stop sharing my screen. And yeah, please tell us how the challenge has been and what do you think you've been able to do that made you what become part of our community spotlight.
Hello everyone. Do you hear me well?
Hi. Yes, can hear you loud and clear.
Yeah, so I'm Nehemiah, and just you mispronounce my name with the mind,
Nehemiah.
the words. Yeah, Nehemiah, yeah. So
Okay.
I'm really excited to be here because for me the journey with Terraform is now just building, keep pushing. But I first started with Terraform just with AI. I was connected with Grace Kiyonge, talking about that. I said that me before I was just working with Terraform and AI. Just I just read one book and just have the structure in my hand, knowing that something like it will go this, master the fundamental topics, and when you have to build your infrastructure, you just uh, created prompt, and AI is doing all the stuff. But in this, the challenge is really different because it really helped me. Each each steps each day is well structure and focus on helping people first understanding the how to what said first the problem, how to resolve the problem, and how to master correctly, not just only let the AI do the job. I'm very focused on coding on myself, uh, creating code and try to see the bug. And sometimes if I face the problem, and try to Google it and say how can I do that. And you myself just working and try to build all things on myself and try to understand, to master correctly. And now I am confident that once I will be in in DevOps interview, like with Terraform. I can confidently well answer all the question, because I become now a master on EIC, It's really helped me, and see the community like with the two Grace. I don't know why they have the same name. You know, I do myself each day working and try to document all I'm doing and making posts and stay consistency in my daily journey. And yeah, I don't know if I mean that's how I can say. And I will want to thank you for this opportunity. I mean I'm the only Connell is here, and for me, it is a very good opportunity because I know once I will be finished with these challenges, I will be keeping building for my community in French. Not really the challenge, but try to create content for all I've learned and how to structure it like you like I learned here, and it is a very good, really good thing for me, and we would like to thank you a lot. Yeah.
Thank you, Naima, and really appreciate you said something very fundamental, letting not the AI do the work for you and understanding the concepts and helping others do the same. By any chance, do you have Zawadi or Kehonge here? Like to also give you an opportunity to say hi to us. If you can raise your hand and we can give you that. If you Grace is here, Grace, Zawadi or Kehonge, if you're in a position to speak. Don't know that the Grace that we have, whether on the room currently is either of the two, but at any point in time, feel free to also put it in the chat. Again, congratulations, Nehemiah, Grace Kihonge, and Grace Zawadi for the spotlight. Again, there's definitely more, and we can't wait to also spotlight you as we get to the wrap-up event, which it seems we'll have to do it as a hybrid event. We thought of it just to be in person, but it's going to be a hybrid event, and we can't wait for us to celebrate with you at the very end of the 30-day challenge. And I love that what you said in Nehemiah, that you want to start creating content in French to support your community right there where you are. Please go on and do that. And if you need any support from us in any way, then definitely ready to support you. Okay, at this juncture, I'd like to invite Nelson, who will also later on maybe invite James to take us through the next phase of this session. Nelson, are you in a position to start your video and also take this stage?
Right. Good evening, everyone. Kevin, please confirm I'm audible.
Yes, you're audible.
All right. Okay. Yeah, that's me. Yeah, so good evening, everyone, from wherever you are. Good morning, good afternoon, depending from wherever you're watching us from. So yeah, my name is Nelson, and I'll be taking you through today's session. It's just a recap of the midpoint of what we've been able to cover the last 15 days. So without further ado, I'll share my screen so that we can be able to do a recap of what we've been covering, as well as do some live debugging together, and also remind ourselves what has been happening all over. So yeah, let me just share my screen. Kevin, my screen is visible.
Yes, it is. Yes, it is. We can see it.
Okay, thank you. Yeah. So basically, sorry, I zoom in a bit.
I think it's someone who's just unmuted. Let me check. Let
Okay.
me check. Uh, yeah, you can go on.
Okay, so yeah, um, the first thing that we are supposed to do is that these challenges for the participants for the 15 days. We are going to have a live terminal and also the VS Code and also our AWS console. I've already done AWS credentials. I've configured my AWS uh, access key as well as secret access. So I've been able also to create an S3 bucket from here for that case. Maybe I'll show that. And then what we'll cover is day one. First of all, maybe I can ask what is Terraform? Before Terraform, maybe I can showcase what really happens. Let me just open my AWS. I don't know if I am having an issue with my internet or what is happening. Okay, before that happens is that before Terraform infrastructure looked like you just go to AWS and then probably let's say you need like 10 of EC2 instances in three environment at 2 a.m. probably, for example. So what happens is you'll click around your AWS uh, console or your AWS UI, but that has now been overtaken with the infrastructure as code. So what we do is that first we have a version.tf where we version our infrastructure. This is where Terraform learns what providers and plugins it needs. So for example, here we have been able to define Terraform and the Terraform version. And then our providers, AWS is our main cloud provider. And then we have this is a HashiCorp AWS and it's using version 5.40. I will have other versions for day 14 and day 15. This is another version for Datadog. This is a provider also. This is a monitoring tool. We also have another provider. This is a DNS provider, Cloudflare. And then these are random. They are used to generate unique resources or resource name suffix. So the first thing is we need to have providers. So for our case, we are using AWS, HashiCorp AWS version 5.40, and then we have Datadog 3.39. So basically that was what day one was supposed to cover. What is Terraform? What is infrastructure as code? And also from your terminal, if you run here Terraform dash version, you need to have an output like this. So it means you have Terraform installed. And also if you have AWS CLI installed, you'll have the version also installed as well. So that was what's supposed to cover day one. Then we had the required version that has explained. So one file is declarative, version is pinned, then reproducible, it is reproducible on any machine. So Terraform configuration language, it's a declarative language. So once you run it, you can be able to declare it and reproduce it on any machine. So that was what was supposed to be covered for day one. And then day two was setting up the environment. So setting up the environment involved, we can go here, this readme here file. The concept here is just initializing Terraform, formatting and validating. So that's basically what was supposed to happen. So from here, we can do Terraform init, and then I'll show Terraform folder that will appear there. So what happens when you do Terraform init, it downloads the AWS Terraform providers. It downloads the AWS plugin. So I can do that. Maybe Terraform init is like npm install. If you have worked with JavaScript or yeah, you do npm install when you're working with JavaScript and those kind of tools. So when you do Terraform init, it's like just npm install. It fetches the providers declared in TF version. So when you do Terraform init, what basically is going to happen is all these versions that we've declared here is going to pull them. So once we do that, we'll have a file. We'll have a file under Terraform that is going to get created. So we can do that and see what happens. Need to go to the shared folder where our files are, sorry. So now we can do Terraform init from here. Yeah, so it's going to initialize.
I know some people are asking whether you're stalking. They're feeling like you've been too silent for too long, or the debugging is real.
Okay, bug so that I can explain. Just a moment. Or we can debug together.
There's someone who has put, George, who has put something in the chat. You can check it. Something he has put in the chat. It should be variable tags or something.
Oh yeah, seen that. Let's give it a try. Mm. Mm, I have been a bit busy today, so I had not tested this code. So you'll bear with me. We just test it together and we will debug together. Mondays are quite busy, so I was unfortunate to be able to test the code. So yeah. To give the code to Cloud to bug for me. Cloud. Okay. Yeah. All right. Maybe we can go through together this code that I've been able to generate. I'll start with the compute variables. So here we have the variable for the name prefix. It is a string. We usually have different types of variables. You can have a string, have a boolean, can have a number. So this is a string variable does instance type, mini size, and maximum size. I think we are going to have auto-scaling groups. So that's why we are having minimum size and maximum size. That is the number in terms of their variables. Then we have subnet IDs and the public IDs as well. This is a variable key name. It is a string. And also we have the tags. So what I want to show you is after we initialize Terraform init, we are going to have the Terraform is going to download the AWS plugin. You can see from here, it's downloading Datadog version. So if I go here to my version.tf, like I showed you, is we are going to have HashiCorp AWS, we are going to have Datadog, Cloudflare, and HashiCorp random. So it is downloading the providers. So as we wait for Terraform to download the providers, it creates a folder where it's able to fetch and store the providers in a declared version, that is the version.tf. So from here you can see Terraform usually use API to communicate. So it is communicating with Datadog cloud provider, communicating with Cloudflare. Then we have HashiCorp. We have HashiCorp AWS version. So it has installed HashiCorp version 5.1. All these we've declared them here. So this is the HashiCorp provider, this is the Datadog, this is the Cloudflare, and then this is the HashiCorp random. If you go back here, let me just collapse this and come back here. We'll see from here, it has already created a TF state file. So by the version of now creating, by the version of it now doing Terraform init, we've already have a file that is being managed where we are going to manage our resources or our infrastructure. So from here, this is the main.tf. This is where we are going to have this file is like the conductor. I've been able to do some comments here. It declares providers and calls every module. The actual resources definition lives here. So day one, we have providers block. Day three, we have the bastion hosts. We are going to see that. And then here we have the Datadog providers that is configured when enabled. So we'll have the data provider, and then it is going to pull the Datadog API key, which we are going to define it as a variable. So we are not going to hard code it. You can see from here we are going to define it as a variable. Then we have Cloudflare provider. It's going to have an API token. We are also going to define this API token as a variable where we don't hard code it. So we can see the standard way or the recommended way of doing it here. And then we have the random ID. We have the byte should be 4. And then day 4 and day 8, where we are creating networking modules. We are going to provision VPC, public and private subnets, internet gateway, routables, and NAT gateway. So from here, we have modules where the source are the module networking. Then we have the name and the prefix. And then we have VPC, CIDR. Then we have the public and private subnets. All these are modules which have been defined from here. So we can be able to see from here. If I go here, I'm going to see, and I come to the compute. I come to the main.tf. I'm going to take you through all these. We can see that Terraform has been successfully initialized. So if I go here, sorry. So nikikuja hapa, you can see this is what Terraform is able to fetch. It fetches providers declared in a version .tf. This is just a JSON file that has been pulled once you declare your Terraform init. The next thing is you need to format your files. So the code that you use is Terraform FMT. To make sure that your code is in the right format. So yeah, so our code is in the right format. And then what we are going to do next is we are going to Terraform validate. Terraform validate is able to catch syntax errors before plan. So in case your code has an error, Terraform validate is able to show you any error that is within your code. So we can run that and validate our code. So it's able to check code. Yeah, so the configuration is valid. Then maybe we can be able to see now the Terraform version that we have. Yeah, so we can be able to see that we have Cloudflare, we have Terraform, Datadog. Datadog is just a monitoring tool. We are going to see how we are going to use it. And then we have Terraform HashiCorp AWS. That is the HashiCorp Terraform is able to communicate with Amazon Web Services. That is our cloud provider. Then we have the Terraform HashiCorp random as well. So we've been able to download the AWS plugins. So what we are going to do is for the day three, what you're supposed to do. Now we have finished day 1 and day 2. I'm into day 3. Day 3, what you're supposed to do is I can come here. We are writing our first resource, running Terraform plan. So the command to run plan is plan, just the Terraform plan is just to run a Bastion instance, and then we have the module security groups as well. So what you're going to do is on the day 3, we have our main.tf file here. We need to run a Bastion file, a Bastion. We create security group for Bastion, application load balancer, app tier, and RDS. So these are the definition here. And then this is a Bastion host as well as here. So we are going to have the instance type, the subnet ID, VPC security groups. And you can see from all these are shared files. So this main.tf, this is just our main file that declares and calls every module in our resources. So what we can do is we just go and run our day 3 from here. I'll copy this command and paste it here. So Terraform plan, and then we have the target is equals to AWS underscore instance dot Bastion target module dot security group. So if I go to my main.tf here, I want to go to here. Yeah, this is where we are defining our Bastion security group. So I'll run that. So yeah, that has run. So the next thing we'll do is to apply. So the Bastion instance is going to get created. So you can see it's creating a networking a module called module.networking AWS underscore VPC. Then we can go to our AWS instance. I want to just go there. Hope is my AWS. Okay, yeah. You are supposed to have created an IAM user, but for me, I'm using root. Let me just put my code. I am guessing that everyone has done this. So, okay. Sorry. Check. Which email is this? Not this. A different one. Yep. So yeah, this is it. Let me log in. let's see, we have an error. So error creating security group is into okay for request. Invalid character security group on the module. All right, we'll go there on the under security group main.tf line 10. Okay, let me see what's the error here. There's a dash somewhere. Let's see it. Yeah. So you're going to create a AWS security group for Bastion. And then we are going to create the instance, still creating. So we can be able to check if the security group has been created. Um, there is a day for debugging. So yeah, just go there. Yeah, so we have the security group. Let me see the inbound port 22. Yeah. So we are going to fix the application load balancer on line 41. Terraform does not recognize dashes, so I think my code has had some few errors. So from here, we can be able to see that we've created a security group called Terraform Dev Stage Group Bastion. that will open our SSH port 22. So what is now creating is we need to create our EC2 instance called Bastion. So, but it is also creating a security group. And we have an error on 75. So we are going to change this code. Let me just sort this and once and for all. Let me just grab damn. Okay, this is output. So let's fix line 111. It has an issue. So I get this from here. It's just see. This is a security group for the database. We are going to that, replace with that. Then sorry if I'm not explaining everything because of time, but I'll try as much as I can to explain what we are doing. But I believe that it's just a recap of what we've been doing. So maybe you should have an idea of what I'm doing. So if a resource has already been created, it's not going to create it fresh, it's just going to skip. We're just now going to create our security group. Yes, so two resources have been added. We have the Bastion IP. We need this IP. So I'm going to copy this IP address. We have the subnet, which are in private, and also we have two public subnets. So if you can be able to just go through this code, through an overview of the code and whatever it is able to do, from here is we are creating an application load balancer on HTTP port 80. We are opening port 80 and also ingress port 443 for HTTPS. Then traffic outside, and then security group only accept traffic from application load balancer and Bastion, so not the internet directly. So we are going to do a HTTP and HTTPS. You can see that we open port 22 as well. So we expect you also have an inbound rule as well. And then for the database, it's only going to accept traffic open to port 33, port 3306. So if I go to my main.tf, which is the main file, we can be able to see where these resources are being created from. Sorry, it's from the main.tf. That is the networking. So this is where the networks are being created. So we'll have an internet gateway, we'll have public subnets, which have been able to create. We'll have public subnets, and then we'll have private and public route tables. And then day 11, you have a NAT gateway. So I've been able to combine this code. It's just combined because I merged all the days and what you've been able to cover into one code. And then you have private route table. So from here, I can be able to go back to AWS. I go to my VPC. We've been able to create this. Then if I go to subnets, you can see we have two subnets, one in zone 1 east 1 US East 1 and another one in US East 1B. That is zone A, zone B. The other one is public. The other one is private. So we have two private subnets. One in US East 1. Then the other one is in US East 1B. Then we have public. And then if I go to the root tables, I can see that I have been able to create this root table here. And then it has the subnet association. And then if I go to the internet gateway, I can see we've been able to create the internet gateway as well. So we can be able to check it is managed by Terraform. These are the variables that we'll be able to give it. Environment is the development, team is DevOps, workspace is the default workspace. If I go to the NAT gateway, I will not yet create the NAT gateway because I think it's in a different day. Then if I go to the security group, all these are the security group that we'll be able to create. So this is for the Bastion. So the Bastion, we need to SSH it. So that's why we've been able to open port 22. The other thing is, I'll just show you. This is a security group for the application. So we have port 22 and port 80. And then we have another security group for the load balancer, application load balancer. So here we have the port 443 and port 40 for port 80. If I can go back to where was it? Where we were seeing we had the networking. We had the HTTP trying. Oh, security, sorry. So from can be HTTP 80, this is application load balancer in port 443. So that's what we've been able to do that. And then we have for the database, I expect port 3306 to be open. That's it. So that's what we've been able to showcase from here, 3306. And then we've been able to open port 22 for the Bastion. Yeah, so since we have the public IP for the Bastion, we can be able to uh, show the Terraform output. Maybe if I copy this and run it here, it's going to give us the same IP for the Bastion server. Yeah, so here it is 44 the IP address is 44.200.127.58. We can try SSH it. I don't know if I have my SSH key here. What is the name of my SSH key? Let me just check on the terraform.tf vars. My key pair. My key pair EC2 dash user 44.200.127.58. That's fine. I think it's right. Just do this. Just find my key pair. Yeah, so we've been able to log into, So what happens is, if you have too many authentication failures, you can use identity only is equals to yes. So that's what you do it. So that just you specify, I just want to use this key pair. So you use this input just to instruct your command. So we've been able to log into our Bastion host, and it was already created. So from here, we can be able to see the EC2. So that's how you basically create resources. I'm hoping that everyone is not a beginner. That's how you have some knowledge of what you've been able to do. Yeah, this is a Bastion server that you've been able to SSH from here. So I'm going to exit that. Sorry. And that was all about the day 3, just to make sure that these instances being accessible on SSH port 22, and then it has a security group as well. So if I open this server, I go under security here, I can see it has a security group and it's only accessible to port 22. There's a way you can even map it to your specific IP address. So if your machine's IP, so there's a way you can secure it in that way. So that's it. I think that was it for day 2. Just go to day 3. Sorry, go to I don't know if you widen up with yeah, that's it. Everything will just be okay. Every resource has a type, so that's the AWS instance. So the plan was just to show exactly what will happen. So we just typed yes, and the Bastion security group as restrict SSH to your IP only. That's where the security starts with day 3. So I've been able to show you that you can only how to secure your EC2 instance by only making sure that it is only accessible to that specific port. So that's the only port that we've been able to open into this instance. So you can be able to see the inbound rules on the security group. It's only accessible to port 22. So it is accessible from any IP, but there is a way you can map it to your public IP or your machine's IP. So on to the next, I think this is day 4. For day 4, what's the concept is making code reusable with variables and exposing values with output. So what we are going to do is we are just going to run this Terraform plan. Variables is equals to banana. So I have different environment variables here. I have a dev and a production. So this is where it is referencing. I have a development environment and I have a production environment. From here, I have also the Terraform TF vars. The Terraform TF vars, these are development defaults. This is how you supply your variables without editing variables. So you never commit your secrets. Password and APIs go in. So environment variables, you call them as a TF vars underscore maybe DB password. So you don't hard code them. And then we have AWS security secret management, which stores the parameters. So what you're going to do is we're going to our day 5 here. Sorry, our day 4. We are going to execute Terraform plan var equals environment so it's going to fail. Reason because I'm going to show you. I'll open the shared folder. So I'm going to go to the shared folder. So if I go to the shared folder here, okay, let me go back here. Let me see. Variables the TF, yeah, that's what I'm looking for. Um, okay, Terraform the TF files. Environment is the development. All right, so from here, this is where we define our variables. I think before was working with variables and make your code reusable. So instead of hard coding your variables, we declare inputs here and supply variables via terraform.tf-vars. So if you come back here, you can be able to see the Terraform TF-vars. We've been able to make these variables reusable here. So if I come here, the variable project is a description of the project name. The type is a string, and then the default is the TFC. If you can see, our resources have been created with this string name. And then validation blocks and force rules plan at a time. So this validation is a length dot the project. The project must be a lowercase alphanumeric and maximum of 8 characters. Being able to see as we are checking our ALB, the tags and also the variables that have been able to be created as well. And then we have the variable environment. This is the deployment environment. We have development, we have staging and production. So these are string, and then the default is the default value in the development environment. We have the validation, which contains the dev, staging, and the production. So it calls this variable var.environment. So if this environment does not exist, it's going to throw an error. Environment must be dev, staging, or production. Then we have the region, AWS region for all the resources. We are going to use US East 1. And then we have the common tags applied to every resource. And then we have networking, these modules, the CIDR blocks. This is a string, and then we are going to use the default CIDR. Then we have the variables for public subnets, and then variables for private subnets. These are the day 3, day 5, and day 10. A my ID for EC2 instance, the string. This is for US East 1, for Amazon Linux 2023. And then we have the instance type. This is a string. We are using T3 micro. And then we have the security groups. The minimum number of instances should run in a security group. Sorry. The ASG, these are the instances that we're going to create. So we'll have going to have a minimum of 1 instance and then a maximum of 3 instances. Sorry. Then the desired should be 2. So at any given time, we'll have 2 running. And then we'll have for day 11, this is the conditional for the bastion. we set to true to deploy a Bastion host in the public subnet. This is a Boolean. So a Boolean is yes or no or a tick or what is it called? The other one. And then we have variables for Bastion allowed CDR. So our IP is allowed to SSH into the Bastion. We can be able to see this. That's why I was telling you restrict this to production. So for now, if I give you the public IP and I give you the key pair, you can be able to SSH to that server. But in production, what it does is we limit to that machine's IP address. So this is accessible to anyone. But what in production we does is just restricting it to a specific IP. Then the name of the existing EC2 key pair, that's it here. And then we have the RDS instance class. We are using db.t3 micro. And then the name of the database, and the master name, and then the password. We are not hard coding the password. So master password for RDS, leave empty. It is going to read from the the secret service manager. And then we are going to set true to deploy the RDS instance. And then this is a Boolean. The default is false. And then the other variables is to set to true to add a net gateway that is needed for private subnets. So this is default off by default to save cost in development. And then we have Datadog. So we are going to set to true to create Datadog monitor. The other variable is to enable Cloudflare DNS. And then the other one is Datadog API key. And then we have Datadog app key, Cloudflare API token, Cloudflare zone ID, and then the host. So that's how you declare variables. I think that was most of the day 5. You don't hard code variables, but you call them. And then now you have like a terraform.tf var, so where you're going to uh, make sure that all the variables that you call them, now you can be able to keep them here. From here, you can be able to see the AMI ID, the ASG, the ones that I was mentioning. This is going to enable Bastion, enable RDS, enable gateway. So here we are going to replace with our own IP in case we want to make these EC2 instance only accessible to my IP address. The SSH key name, this is my key pair, then the team is DevOps, then the challenge is that it is challenge. So that's how you deal with variables. On the day 6, this is just the concept is moving state the S3. We are just going to move the S3 bucket. By now, I know you know, we are just going to move the state to S3 plus DynamoDB for team safety locking. By now, I know you know what is a remote RTF state. And I think I had also mentioned on it on the wall that RTF state or it is a blueprint. This is your blueprint of the resources that you are creating. So at any given point, you should not edit your backend.tf. So what we are going to do is we have our backend.tf here. This is it. You can replace with your own unique suffix. So this is the challenge, TF challenge. Then we have it is on the US East 1 region. The encryption is equals to true. And then we are going to use a dynamo underscore table for TF clocking. What it does is that when probably I do Terraform apply and we are working on the same resources or we are working with the same infrastructure with a colleague, if both of us uh, press Terraform apply or just execute, we are going to have a drift or we are going to have a corrupted infrastructure. So what Dynamo table does is that at any given moment, only one user or one dev can do Terraform apply. So it is able to help you in making sure that your file don't get corrupted, and then there's no drift as well. So here what you're going to do is, let me just see on what you're supposed to do on the day 6 on the README. They say this is the concept I was trying to tell. Two engineers are in the same laptop. Let's give a scenario for at 2 a.m. run Terraform apply. So what really happens is, without remote state, one overrides the other. So the infrastructure is going to have chaos. So what you're going to do is you're going to do a live migration. Already we had done Terraform in it. And then, what you're going to do first is to verify this. We're going to verify that we have our S3 bucket available. So we are going to run this command here. Yes, we have our terraform.tstate. Maybe I can also confirm it from our AWS instance. So I just go to our Terraform TF S3 bucket. I had already run this because I had run a script. There's a script I had run here for Bootstrap. So I've been able to bootstrap this. I've been able to configure this, then create the bucket, and let's also create the dynamo DB state locking as well. So it's just a script that I was able to execute to bootstrap the same. Since we have that already, I think the UI is taking a bit. So what I'm going to do is maybe I can do two terminals. I can show you with two terminals. I don't know if my machine is going to freeze. Okay, but from here you can be able to see the bucket that we created, the name of the bucket. Just here, the name is TF Challenge State Nelson. So this is it. Yes. So it is here and version is enabled. So yeah, this is a landing zone. It has that folder. Then we have the terraform.tf state. So a terraform.tf state already it is here. And then the version, I think it's already enabled. Yeah, you can be able to see the versions that we have already. We have a version that was at 9 p.m. We have the 2058. So in case anything happens, you can roll back to the most safest version. That's how it happens in production. So with that, I want to show you maybe, let me just try to close some tabs here because I know my terminal is going to freeze. I'm going to open two terminals. I don't know if you're able to see my terminal. Kevin, is my terminal visible?
Yes, we can see your terminal.
Thank you. So I'm going to just go to the project, then see the Terraform database challenge. Sorry. I want to have two terminals here. So yeah, so I'll have these terminal A, terminal B. Yeah, so what I'm going to do is from these the 6 here, we are going to go to shared resources. That's where our Terraform resources are. So you can just observe what's going to happen. So I can clear that. We just need to do Terraform apply. Then from terminal 2, we are going to do Terraform plan. Yeah, so this we are going to do Terraform apply. Then these are our terminal. We're going to do Terraform 1. So you can see it is acquiring state lock. This may take a few moments. So yeah, then You see, this is the error we expect. Error acquiring state lock. So it is locking. You see from this here, this has been able to acquire that, but for this one, it is locking because we already have another operation running. All right. So that's how it usually happen with that. So it is going to give us an error acquiring state lock. Like that error. Yeah, see this is the error here. So that's what we expected to happen. So with S3 bucket and Dynable log table, that's how we do S3 stores. S3 stores the state centrally, so everyone reads the same version. And then the Dynamo DB provides the distributed lock, so only one apply run at a time. And then versioning of the S3 bucket, automatic state history. You accidentally destroy, you can roll back the way I've been able to showcase you guys from there. So yeah, I can show you the Dynamo DB state lock just very quickly. Just go to the table itself so that we move to day 7. Yeah, so here is it. We have the tier state lock. So this is what is being able to help us that we do execution per uh, every request. So we are not going to do request execution at a go so that we don't have a drift on our infrastructure. So we move to day 7. I think day 6 was about a remote state and then moving state to S3. So I've been able to show you how you just move that and then how you lock it and you avoid drift. So day 7, the concept is a two-way managing multiple environment in Terraform. So we are going to have a workspace here. So what you do is just you run this Terraform command when you are working with workspaces. So when you want to list your workspaces, let me just explain what is a workspace. A workspace is just a folder. Let's say it's just like a folder. When you're dealing with Kubernetes, we deal with things called namespaces. So you can just relate it as just like that. It's like the way you can have different folders in your laptop or your machine where you separate your environments. So you can be able to have different workspaces. You can have a staging workspace, you can have a development workspace, and you can have a production workspaces. The reason we do these separate our workspaces is to avoid maybe having production going down or having maybe teams working on development and you are testing something and then maybe someone touches the production and production is already derived. So we just have to have these separated workspaces to avoid maybe things getting messed up and also having organized your work in a way. So you can be able to see, I just didn't run the full command. This Terraform workspaces, Terraform workspace lists. We are using default for now, you can see. So from here, we are using default Terraform. So at Terraform workspace, we can create a staging a workspace. So what we do is the command for creating a new Terraform workspace is Terraform workspace new staging. So Terraform workspace new staging. Then just hit enter. It's going to create us a workspace. And then now if you want to enter into that workspace, you So if I list the workspaces, it's going to bring now two workspaces, default and the staging. Yes, so you have two workspaces now. So I can now maybe enter into that Terraform workspace. So it's going now to create a new even remote backend TF state, because now we are moving to a different workspace. The default had its own remote backend state. No, now staging will also have its own terraform.tf state. So we are going to select the staging environment. Just select staging. Sorry, staging. Sorry, Terraform workspace. So now we are under staging environment. That's our workspace now. We can run Terraform workspace show. This is a staging. So if we do Terraform plan, so this is just very complete or very separate from our staging and development. So you can see it is acquiring a state lock, and then now it's going to create resources, or you have an error here. I need to check on this error, but we can correct the error. But basically, I hope you guys are getting the concept. Please just show some thumbs up if the concept is all right. The class has been so silent. Okay, thank you. Yeah, so let me just go to my terraform.tadvance .dog. Oh, so I need to input my actual I need to input my actual variables here. That's why it's requesting for those variables. So if it is here on the development, I need to have some variables available here. So let me just look. Yeah, staging. Yeah. Main.tf. Link into line 35. Yeah. Yeah. So they okay. I get it. Yeah. So I need to have set these variables here, but I think we have not created those resources. That's why it's so we can set validate is equals to false. Providers. So once here we can just put validate validate equals false for now, because we may not use them right now. Also for the Cloudflare. Now just put that. Okay. So this so question for these variables. Okay. Need to debug for this. I need to have created all these resources. These resources have not created them yet. Okay. So let's just comment without a comment from here. And that for now. Provider, provider. Okay. We try. Move that down Terraform image. Yeah, so Terraform plan. Okay. Is about this was you. Okay, what I can do is to comment out. Just going to remove the Datadog and the Cloudflare until we are ready to use them. So yeah, so that's it. And then on our main.tf, uh, Something that we need to do away with. That these code just look very dirty, but commented out Datadog monitors and Cloudflare so that for purposes of moving on with this, so I'm just going to terraforming it again. I just want to show you the different workspaces and how the S3 bucket is being created for the staging environment when you run Terraform init and Terraform plan or Terraform apply. So once we do that, we're going to run Terraform plan. Then we run Terraform apply. You can run Terraform apply -- auto approve instead of just typing yes. If you run Terraform apply -- auto approve, just approves your resources automatically. So you're just going to put yes. It's going to create our staging resources. So you're going to see these resources are going to be created on a staging environment. And that's what it's going to do. So it's going to create a VPC that is on a staging environment. It's going to create application load balancer on a staging environment. So let's just go to our resources here. I can go to VPC or EC2. I go to application load balancer here. Can go to this load balancer. Just loading. So yeah, this is a development that is being provisioned. So if I go to the S3, we're going to see different environment. Before I run this, I ought to have done as development environment workspace instead of calling it, instead of having it as a default. Yes, you can see now the environment are different. We have this environment here called staging. It has its own remote backend that is having the terraform.tf state. So every workspace manages its own terraform.tf style differently. If it is a production environment, it's going to have its own terraform.tf state. If it is a development environment, it's going to have its own terraform.tf state. And all those resources are going to be created differently. If I go to VPC, you can be able to see that those resources are going to be created differently. We are going to have, let me just load this. Yeah, so we have tfc.dev, a different file, a different subnet that has been created. So these are different subnets. We are going to have the internet gateway. I hope to have renamed them differently. So we have the TFC dev and these other file that has also been created. I should have renamed them. It's only that I use the default one, so it should have a development and a staging one. And then on the security group, the same thing that's going to happen. You have different stage groups that are going to be created on the workspace. So that's what is going to be created. So that's basically it uh about day 7 on how to manage different workspaces. So you can be able to see the VPC ID. You can be able to see to go there and see. I think is what has been created and be able to see. Yeah. So there, yeah, from there. If I go to the load balancer, it's on the EC2. Going to also to create another EC2, I guess. Go to the instances. So here's the staging, and then just created another bastion as well. So that's it for day 7, just managing workspaces. If I come here, the shared file, uh, I have been able to show you the different S3 buckets. So we have state isolation, same backend, different keys, they are fully separate. So even if you have different code for if you have different passwords for staging and production, that's how you separate. So this is how you reduce risk, and then easy to apply to a wrong workspace. So you explicit. So then the rule of thumb is that you use file layout for production and development. And then these are like branches. It's the same way that you have a branch in GitHub. So that's how you work with workspaces. And then that's how you even you manage different workspaces using the S3 bucket. So it's going to create a different TF state file. And then from there is the day 8. Day 8 was extracting reusable code modules for dry infrastructure. These just having the networking modules where you just reuse your mod instead of every time. If you are using these modules all the time, you don't need to keep repeating them. So from here, maybe I can be able to show from, I guess, the 8 somewhere here. It's somewhere here. The 8. So yeah, you can see we've been able to create staging and development modules using the same module. So we didn't have to repeat the module for creating a staging environment and also a production environment. We just reuse these all modules. Even the networking, we've been able to reuse the modules. For database, I know it's going to create another database. For module, it's going to create all these resources. If I go to ASG here, I think auto scaling groups, you can be able to see that's going to have different, yes. So it has one instance, one desired, maximum is 2. And you can be able to see those instances are here down. So the instances has already been created here down. So yeah, so that's how you reuse your modules. You don't have to, if you have a development, you have a staging environment, you don't have to define each and every module. You just reuse what you have. So that's how we reuse the modules. Basically, that was it for day 8, I guess. Yes, it was just how to reuse the resources. Module purpose here, it is the networking, the security group, the compute. So all these modules, you've been able to reuse them differently on different workspace or different environments. If that it is a database, you've been able to create it afresh on a staging environment. It's able to create on a production environment, but you're not defining it like we are saying this for production, this for development. The same modules, are just reusing them, but on different workspaces. You can see even the security groups, they have been able to create the same security groups, but for different workspaces. I hope that's well elaborated. For day 9, day 9 was all about module versioning. Uh, so here what it is just how you version your modules. I've been able to show you the versioning, like for example here, version 5.40 means uh 5x but not 6. So it is just saying that uh less than or equals to 5.40, but not greater than 6. So version constraint, we have version 5.40, this exact version that is rarely used. And then we have greater or equals to 5.40. This is a version or higher. It is loose or risky. Then we have version 5.40, that is only for patch updates and it's recommended. Then we have version 5.0, which has minor updates and are common for providers. So when you are updating your infrastructure, just make sure that you know the versions that you're having. So that's what we are saying, that module versioning. Make sure that you don't version your infrastructure and then it breaks your production environment. So from here, I was able to show you the version.tf, all the providers version pin, they live there. So it is just a permissive constraint operator. So this what we are saying is just reproducibility. Same Terraform init results today, then the next year on any machine. So we commit Terraform log.hcl in real projects. It is the exact provider hash. So it's here. This is what I just told you. This is just a JSON output. You can be able to see here we have version 5.1 and then the constraint I have version 5.4. So in case you just change your version, this is the provider's registry. Now you are going to break your production. So that's why you're saying that when you are doing your versioning, you just have to be careful. Even when you are doing your versioning upgrade, I think there's a way you are supposed to do the versioning upgrade as well. So that was about the module versioning. I'm just going to go quickly because of time. For day 10, it was all about loops for each and dynamics. So the concept here is a key-based iteration with for each elimination. For example, this is what we mean is if a database is attached to a VPC and you want maybe to for example, there are things we call in Terraform depends on the other concept like count for each. These are able to give the key difference. So, for example, this code here, here the AWS subnet public, we are going to have a defaults. The first subnet as 0, and then the other subnet is going to be as 1. So if you remove 0, 1 becomes 0. So if the Terraform destroys, it recreates it because you've already defined that. We have already defined that infrastructure. So if we are defining your subnet, your first subnet as 0 and then the second subnet as 1, if you delete this subnet 0, then this one becomes 0, and then the other one that is going to be recreated becomes 1. So for each key is based on that. So it removes the first, and then the second complete gets untouched. And then for each in the networking module, we have for each, for example, in this code, we have how you call these variables, or how you define these infrastructure. For example, on the dynamic block in security modules, for each equals is just a syntax of a code here, variable dot bastion underscore ingress rule. So from port, ingress dot value from port. So it's going to define this port from here, and then to port this. Then we have the protocol, and then we have the CIDR blocks as well. So without dynamic, you'd repeat the ingress block for one rule. So here on the main.tf, maybe I can just show what I mean very quickly. Dynamic ingress block. Let's look for it. Yeah, here. So this dynamic block replacing writing the same ingress block 3 times. So instead of just writing these, we keep repeating all these infrastructure. We just define it with one command from here. So this rule is just going to apply for all the infrastructure that we are going to define it from there. So so the taking points here is used for each of account whenever items have natural stable key like CIDR or name or ID, and then dynamic replaces copies pasted or nested blocks. So if you've written the same block 3 times, use dynamic for each key and each value. So these are loop variables inside A for each count resource. So for the day 11, this was toggling resources on off by environment using conditional locals. So for this, maybe we can do a Terraform plan here. Just run this command. So what it's going to do is this variable, let me just explain. With this command, what it's going to do is Terraform plan is equals variable enabled Bastion false. So it's going to delete this instance. So the output will be instance Bastion 0 will be destroyed. If we say the Bastion is equals to true, it is going to be recreated. So in HCL, in local.tf, let me just go to local.tf. So here what we do is naming convention. So the name prefix, variable project, variable environment. Availability zone are pulled dynamically so that code works on any region. And then we have the desired condition. For example, the bastion count is a variable dot enabled underscore bastion is equals to 1 or 0. So then we have the RDS count 1 or 0. Then we have the NAT gateway is equals to 0. So you can see that it has been no infrastructure changes has been made because it is already existing. So if I go back to the 11, in the main.tf on the bastion file like this. Yeah, so you can see count is equals to local dot bastion underscore count. So if I go back here to local, bastion underscore count is equals to variable dot enable bastion 1 is to 0. So that's why we were running this command here. Yeah, this the 11, yeah. Bastion is equals to false because false is treated as a 0. I'm going to delete this instance. The output was that. And then if the bastion is equals to true, the bastion 0 will be created again. So the local.tf prod get large instances automatically. Then effective instance type variable dot environment like production T3 is small as a variable instance type. Then we have effective ASG dot minimum. Then we have variables dot environment. So we have the maximum and the minimum. So one code base, different behaviors per environment. We have 0 duplications. So the features here is that variables, dev, and production. If we enable Bastion and true false, we use secret service manager. And then the checking points here is never delete resources to turn them off. So we use count. Count is equals to 0. So local.tf is where expression live. Keep main.tf clean. So like your local.tf is going to define your infrastructure, the maximum capacity for production. You can see from here, it's even the instance type production should be T3 small. All those items are able to be defined here. You can see even the variable project and the environment and even the workspace. So that is it for, I guess, that is day 11. For day 12, it was all about zero downtime deploy rolling AMI updates with application load balancer, and then create before destroy lifecycle. For example, let's say you cannot delete an EKS cluster and it has running pods. So what we do in Terraform, we have things called create before destroy or destroy before create, that in any case a resource has to be first deleted because before another resource is deleted or another resource is created. Like for example, if you want to set up a cluster, you'll have first to have the nodes ready, then the cluster can be, or the cluster has to be ready so that the nodes now can spin up. And then now when deleting the cluster, you have to delete the nodes first. So that's why we have this life cycle. We have the make sure the application load balancer and ASG are deployed from earlier steps. I think we have that. We can watch this. Just do this very quickly. As that does that, maybe I can just explain this. So from here you can see AWS launch template dot application lifecycle create before destroy is equals to true. So new template exists before old one is gone. So if you are deleting old instances or old resources, new ones has to be created first before the others need to go. If there are EC2 instances that you're destroying, those that are being created has to be created first before the other ones that are being destroyed to go, so that you don't have you don't have downtimes. You don't have to have an experience where your resources have been destroyed, your EC2 instances have been destroyed, or your infra has been destroyed, and that infra was being used. So what happens is that infra has to be created first before the other ones is destroyed. The same thing has to happen to the scaling group application. Instance refresh strategy is rolling. So minimum held is at 90%. So at most 10% of the fleet at down. So this one is going to have a threshold that is going to keep checking. So the life cycle is create before destroy. The same thing happens to application load balance at target groups, where the registration delay is equals to 30 seconds. So application load balancer wait for in-flight request to complete. So how it works, it is the MI ID changes in the TFVers, then new templates version created, the auto-scaling group instances refresh and trigger the rolling replace, and then new instances boot plus register with the application load balancer target groups. Then the ALB health check passes, traffic shifts. All instances drains after 30 seconds and they are terminated. So create before destroy reverses the default order. Terraform creates these and replaces the first ones. So minimum health percentage is equals to 90%, 90, which means at most in one or in 10 instances is replaced as a time. So the application load balancer is a traffic gatekeeper. It only routes instances that pass health check. So if an instance has not passed a health check, it cannot be replaced. And that's the work of an application load balancer. So let me just see if I can be able to showcase that practically. Or maybe we can do this. Can just simulate something new here. I want to see what new instances come up. Yeah, so let's just check the other instances that we are going to come up. Yeah, so we can go to our AWS, go to EC2. Let's say we are going to see new instances being created and others are going to get terminated. But they are going to get created before they terminate. Yeah, so you can see they have been terminated and these other ones have been created. Just click yes here. Just refresh this. So you can see there's some that are initializing. We can be able to check our application load balancer if it is healthy. I just go to it. Uh, Balancer is here. See the resources are still being created. Yeah, that has already finished. We want to see the load balancer is if it is healthy. Let's go to monitoring. You can see if it has started receiving. Yeah. Username roles. Okay. Okay. Mm. It's unhealthy. So yeah, you see, and check. So let's see what instances are there. And they're still initializing. So yeah, I think that's it. Then for the 13, it was about sensitive data, keeping secrets out of code. So what happens is we have 3-level demo, can be able to do this. I'll just show you what happens. I'll do a Terraform plan. Variable is equals to DB, password is equals to super secret. So this is where I'm going to showcase that our database password is going to be visible to everyone once I store it into our infrastructure. So what's going to do is So what we do is the best way is to have a secret service manager where we call this, we put it on a secret manager, we secure it, and then we have the default password. Then Terraform reads it via a data source. It's never in the TF vars, it's never in Git. Then the SSM pattern, where the main.tf reads the password from the SSM at place in time. So we can have that on the main.tf on MySQL, I guess, here. Yeah, so it's able to read the password from here. Can be able to see data.aws ssm parameter.db password 0.vary. So we are not hard coding it. This is a recommended way to store your database password. And then if it is sensitive, it is also always equals to true. If your variables are sensitive, it should be equals to true. Like for this, API key or the app key should be true, sensitive, true. Anything that is sensitive should be true, so that when you are having the output, it's not going to print out your, it's not going to print out your variable or your password. So it's something that is sensitive, like API key. We have the Datadog app key, the API key. Have this as sensitive is equals to true. So yeah, so that's the 113 working with sensitive. I can be able to see that these have been able to do that. Then you have git ignore, have a git ignore where you are ignoring uh, your resources, tf state, tf backup, tf state backup, secret dot variables, all these just make sure that even your pm dot uh, your key file don't expose it to the public or push it to GitHub. So yeah, that's it for day 13. I guess it's about security and it's very important. Sensitivity is true. It hides the values from the terminal, but not from the state file. SSM secure string encrypt at rest with KMS. That is the key management service. And then only IAM authorizes role and can decrypt. The database module intentionally has no DB password output, and then it reads from the secret manager directly when needed. For day 14, yeah, I think I had the secret manager here. Just uh, can just show you how I stored my database password from this resource as we wind up. I know time has really gone. I think I'll be finishing in the next 5 minutes. I don't think I created any secret there. But anyway, that's how you can be able to create a secret as well and use the secret manager as the service to store your database password. For day 14 is Terraform manages any platform with API, not just AWS. Like I showed you, if you are dealing with Datadog, we are going to export the API key for Datadog and then the API key for the app key for these, then we are going to apply the variable. That's how Datadog and Terraform are going to communicate. So we can be able to open Datadog in the browser and watch and monitor application as they create. We did not create the Datadog, so that's why we are not going to proceed with this. But for the version here, you can be able to see that AWS resources HashiCorp, AWS Datadog stroke Datadog. This is software as a service, not AWS. And then the main on .tf, we have the provider, that is the Datadog. And then we are calling the API key for the Datadog and the app key. Then monitor is created. All these, it's able to check your threshold and the application load balancer. So Terraform manages anything with API, cloud, SaaS, DNS, database, monitoring, all from the same plan and apply. So the Datadog resources is the same count. That is the variable enabled Datadog. One is to zero pattern from the 11. Then tag works across providers managed by Terraform, which appears in both AWS and Datadog. Credentials go environment variables, .tf vars, and never in TF. So that's it for day 15. Mostly it was wiring AWS output, Cloudflare DNS in a single Terraform apply. I think most of the guys have not covered this. Maybe I'll not touch this much. Uh, yeah, because of time as well. But I'll just stop it at there, Kevin. Back to you. And thank you for even the 21 guys who remained behind and following through. I hope you've not slept. So, Kevin, I wish to stop at that point and thank you so much.
Sure. Yeah, it's quite I can say amazing to run through 15 days worth of the challenge in just in like 2 hours. It's not that easy. And I believe the people who have participated in this and also those who are going to be checking it on YouTube later on will gain a lot of amazing insights. I think as what Grace mentioned earlier, she said that the goal is not only just to complete the challenge, but to complete it with a deep understanding on how and why things work in terms of infrastructure as code and how it relates to real world scenarios. So that was quite something. And thank you so much, Nelson, for taking us through on that. At any point in time, again, you're not just supposed to do one day of the challenge once and you think you've already gotten it. You can even go back to day 3 or day 4. For example, yes, earlier today I was saying someone else is in day 2, another one is in day 15. And that is exactly what we wanted in terms of you getting that flexibility, in terms of you not having that feeling that you're being left behind, because we already understand that people have different paces when it comes to learning these things. But the most important thing is try to connect one concept with another. Try to connect workspaces with modules. Try to connect state locking with drift detection. And those are the different concepts that you're getting from this particular challenge, and see how they can come together for you to build like infrastructure in a way that follows best practices regardless of the cloud provider. Because here you're not learning AWS, you're learning infrastructure as code and Terraform. So just don't be bogged down with things around the services, around AWS itself, but especially around the concepts behind Terraform itself. So as before we call it wraps, I'd like to ask that remember that you're going to be having the wrap-up event. It's going to be a hybrid event in advance. It's going to be tentatively on the 18th of April, because the challenge officially ends on the 16th, thereabouts. I think it should be the 16th of April, if you ask me. And I already made the requests to the HashiCorp team for a couple of things there, here and there. So hopefully once they do confirm, we'll be able to confirm what will be there on that particular day. So please, again, it's not really about the outcome, it's about the process. So let's fall in love with the process, even as the rubber meets the road in the last half of this challenge. Keep on posting, building in public, do your articles, and then we'll be able to see each other when it gets to the 16th or even the 18th in that case. So that is it on our end. And thanks so much for joining us. See you on the next one, on the next pulse check, which preferably would be maybe at the end of next week. Thank you. And for those who are celebrating Easter, happy Easter.